The speed of light, a universal constant that is proved to be a crucial element in various arenas within the field of physics. My name is Adam Fields, and today we will be discussing wavelengths and the frequency of waves, and how are they related? Waves. Not these waves. Not those waves either. Ah, yes, these waves. When referring to the electromagnetic spectrum, a wave is a movement of energy in the form of particles called photons that may vary according to two variables, wavelength and frequency. Wavelength is the distance measured in meters between two successive points on a sinusoidal function. Frequency, measured in hertz, is the number of cycles of the sinusoidal function per second. After the discovery of the speed of light in 1676, it was determined that all electromagnetic energy travels at the speed of light. The speed of light is the frequency of an electromagnetic wave's wavelength. So, the general formula is c equals lambda times nu. C represents the speed of light. Lambda illustrates wavelength and nu represents frequency. The speed of light, to be exact, is 299,792,456 meters per second. It's a mouthful. It is important to understand that wavelength and frequency have an inverse relationship. When wavelength increases, frequency decreases, and vice versa. For instance, with these guitar strings, when a lower note is plucked, wavelength is large while frequency is low. However, for a higher note, wavelength is low while frequency is high. Stand up and move your arm up and down, like this. Next, move your hand in the same way, and next, move your finger in the same way. You should notice that for your arm, the number of cycles per second is low, while the wavelength is large. However, for your fingers, frequency is high and wavelength is low. For a sample calculation, let's say we have a gamma ray with a wavelength of 3 times 10 to the power of negative 11. So, we would use c, instead of writing that long number, we'd use 3 times 10 to the power of 8 to denote the speed of light. We then divide it by the wavelength, which was stated earlier as 3 times 10 to the power of negative 11 meters. By doing this, we can get the frequency in hertz, which would be 1 times 10 to the power of 19. This is how you would use frequency to find wavelength and vice versa.